So hi, this is Piotr speaking. Good afternoon. That's the part 5 of the Quasar training. Just for the recap, in the previous part, we had a look on how to do some sampling of a real data source and how to perform information exchange between the data source and the OPC-UA address space. And in this part, we'll have a look at configuration and adding of configuration data. Now, to avoid any confusion here, what we speak about server configuration is we speak of instances of Quasar classes, and that means particular objects that will be created from Quasar classes. And the instances are identified by name, which is unique. It's guaranteed by Quasar. And the instances might have supplementary data, which are attached to the configuration and which are loaded when the server starts up. The server configuration is stored in an XML file, and this you already saw, I think, in part 2 of the training. And the default name is config.xml, and it stays along the executable. But you can have multiple config files, and at server startup, by using arguments of the executable, you can select which config file to use. So now let's speak about the XML file itself, and maybe let's go back to the real example. Okay, let's maybe speak about now a bit on the perspective of the XML file, of the config file. So we cannot, you can see here, we cannot motor elements, XML elements, because in the design we said that we can have a class called motor, so that propagates into XSD complex type, which is a schema definition of XML called motor, where we have one attribute called name, and this attribute called name is mandatory. And since we did not put any restriction, we can create as many instances of motor in this config file as we want. Okay, at the moment the only difference between them will be their name, which has to be unique. So we have M1 and M2. Okay, but now the point is that in many situations we'll need to attach supplementary information for those motors or whatever other class we would speak of, and let's see what would be the typical applications of such supplementary configuration data. So we usually make OPC-UA servers because they can produce or consume information which is about something, which is representing a state of reality, like state of a chip, of a motor, of production plant, whatever that is. Doesn't really matter. But usually the server will know how to get that information or how to put that information, so how to perform monitoring or how to perform controls in other terms. Now, quite often we'll see the situation where we use another API or another communication interface to obtain or send that information, and therefore quite often we need to have the information which is mandatory to initialize that API or communication. So if we have a server that communicates over network to talk to some device or whatever it is, we might need to have a host name. If we talk over some interface like USB or whatever that is, we might need to have port names. We might need to have network addresses. If we're making an OPC-UA server for an embedded device which would directly talk over SPI or I2C or whatever that is, we might need to have hardware addresses or bus identifiers and so on and so forth. So the question, of course, then is how do we store this information? And our primary recommendation here is that you store this information in the configuration of the server. Apart from this information, often you also need to have information on configuration of dependent hardware. So, for instance, if you perform acquisition of data like ADC samples. You might need to know what's the intended sample rate, all the input ranges. You might need to know the calibration constants, and so on and so forth. So now, how to address this problem practically and how to add some supplementary configuration information. So I go to my design, where I find my class called motor, and let's imagine that in our sample project, our intelligent motor controller can be communicated on is attached to some bus where we can have multiple devices, and each device, each connected motor is under some identifier, which is just an unsigned integer. So I will add a configuration entry here, which will be per every instance of the motor, where I will store this identifier. And I have basically two methods of doing this in Quasar, which are very similar. Actually, they are identical in the terms of configuration. The only difference is on the address space, but this we'll quickly see. So I will start with a simpler mechanism, which is called config entries. So what I'll do now is I will add a child called config entry. It's per motor, as you can see. And then I set I want my identifier to be an unsigned integer. Of course, it might be any other data type supported by Quasar. And I will simply call it identifier. So now let's have a look how it looks in our favorite tool of Quasar design visualization. So I will generate a visualization of a design diagram with a level of detail of 3, which is quite detailed. And I will open the resulting PDF file. So what I see here is that now I added something called CE, which is configuration entry, which is identifier. Oh, this is pretty funny. What happened to this UTF-8? I don't know. Anyway, we have this identifier here, and it happens to be uint32 because I declared it that way. Now, how do I actually use this? So first of all, I have to rebuild my my Quasar 7 because I just modified the design. Okay, and now let's see what it changed in practice. So if I go to my config file now, and I find a way to refresh so-called dependencies, which is in Eclipse is usually reload dependencies. So I click on that. And then what I see is when I click on add attributes, so here we're talking about XML attributes, I see a new possibility, which is called identifier. So this is coming from my design. And this is the identifier, which will be, let's say, the hardware address of my motor on some sort of communication bus, which, let's say, motor 1 will have an address of 1, and motor 2 will have an identifier 2. Now, what's important here is this attribute is mandatory. Okay, so I cannot even remove it. Eclipse is not letting me do that because it's part of the schema. And if you manage to do that kind of by hand by using a text editor, you will see that your server will not start up. All right. So did it actually change anything for the moment that I added this identifier? No, because so far I did not use it yet. So now let's see how can I use this configuration entry in my source code. So here's the method. What I add in configuration will be reflected in a configuration object which will be supplied to the constructor of this object in the device logic, in the address space class, and all of the classes. But what is of importance for you is, since you place your custom code in the device logic, which, as you remember in the parts, I think 3 and 4 of this training, it's this file. It's motor H and motor CPP. So in motor H, you can find the constructor of this class, and you can see it takes something called configuration from the namespace configuration called motor, and it's an object which is passed by Quasar to this class to this object when it's getting created. So this is precisely where you'll find this information about newly added configuration entry. So let's have a very simple example. This is my constructor body, and let's say I will only print this identifier when the server starts up. How can I do that? So let's see what I have in my config. Do I have my identifier? I should have it somewhere. And if not, maybe I did. Ah, yeah, voila, here it comes. This is my identifier. And if you look at this, it should be something like unsigned in. Okay, it's maybe hidden by the type alias. It doesn't really matter. So I'd like to print this out. Of course, you can use some cout and things, but I would actually prefer to use logit, which is what we use in Quasar to perform unified logit. So I will say motor ID equals, and this is config identifier, just that. Okay. Now let's see if that thing builds. Okay. And now if we try to start the server, somewhere, precisely here, it was a place where our device logic for the motor was created, and the configuration was passed, and we had access to the identifier from our constructor body. Which means that when you make a OPC-UA server and you want to have a class which obtains information or sends the information by network, by some hardware connection, by serial port, USB, or whatever that is, this is the place where you can actually open this connection. This is the most obvious place where you can open this connection. It's in the constructor. Of course, you have few other options, so you can ask what happens when I will have to open this connection, but only later on or on request. This will study in subsequent parts. But this is precisely the most default place to open the connectivity to whatever that is in the constructor. Now, so we looked at the config entries in the design, and if we look at the config entry, what's mandatory is the data type and name. There's a few interesting options, a few interesting attributes in addition. So you can put default value. So, you know, the default value will make this attribute not to be mandatory anymore. You can put the default value to be 5 here. In a case of an address, it maybe doesn't make that much sense, but it might make a lot of sense to something like default sample rate or default whatever that is. Then you have isKey, which is a more advanced feature we'll be looking at in subsequent parts. But we have also stored in device object, and this is also pretty nice. Stored in device object means that when it's true, of course, it means that from our device logic, we'll be able to do that. We'll be able to use this identifier in any method from this class, not only in the constructor. Which means if you, for instance, have our update method, which keeps on obtaining information, publishing to OPC-UA, means we don't have to make a copy anymore because this configuration entry will be stored in the device object for the whole time for its whole lifetime. Which means that now instead of now I should be able to do something like this. Also in the update class, the one we wrote in the previous part, which keeps on querying our intelligent motor controller to get new information. So what I can do now is, I think this should work. I hope so. Of course, the Eclipse will probably say it doesn't exist yet because I did not yet rebuild the server. But let me try to do that. Let's see what happens. Okay, so that seems like fine. So now let's start the server. And as you see what is happening, now I'm printing the identifier every time the update is called, which simply means that now, without any effort, you have access to your identifier like during the whole duration, whole lifetime of the motor class. Okay, so that was the config entry. For your information, you can also have scalars here and other more advanced things. Arrays here and more advanced things. But this will cover in more advanced parts. But now let's talk about the other mechanism, which is identical in terms of configuration aspects, but has one more advantage, which is you also can have cache variables, which we covered in, I think, part 2 and 3. You can also initialize cache variables directly from the configuration. So it saves you a lot of time and is also much simpler and much more concise. So let's try to do that. I'll add a cache variable. And my intention is to have something like a update rate or refresh rate, let's say, which will be a frequency in, let's say, hertz, on how often I want to query my intelligent motor controller for what, for its current state. But my intention is that I'd like to have this information initialized to some default value in the configuration, such that apart from having it as default, but such that the end users of my server could have something initialized when the server starts up, and maybe then to also be able to change it from the address space, but at least we want to have some initial value over there. So what I can do here is that I say that initialize with is configuration. So this is the difference compared to part, I think, 2 and 3, where we, as we can get back, we had value and status. Here, I'm saying configuration, and that means that this cache variable name, and here namely its refresh rate, will propagate to the config file schema as well. And well, let's simply have a look. So let's rebuild the server. Okay, now let's try to run it. Let's see what happens. Oh, it doesn't start. Why? So it's telling us that we had a problem with loading the configuration. And why is this? We had a problem at this line and this line because there was a missing required attribute, refresh rate. Why did this happen? Because we wanted to have this information coming from configuration, and we did not specify any default value here. So you can, I suppose, do this by maybe not here, but you can actually you can do that, which I'll show in one of the subsequent parts. But the primary problem here is we did not put this in our config file, for which we again reloaded dependencies because the schema now has changed. And I say add attribute refresh rate, and that would be, let's say, 1 Hz for this motor, and maybe refresh rate would be 1.5 Hz for another motor for some reason. So now let's try to run it. And of course here I don't see any difference because I don't use this information yet in my device logic, but since we added a cache variable, then I think we should see this information in the OPC-UA address space. Let's have a look. Okay, we can have a look here, and now we see there's a refresh rate, and this is 1 for this motor, and this should be 1.5 exactly in the other motor. Okay, so a quick takeaway. So we in this part we had a look at config entries and at cache variables which are initialized from the configuration. And why we usually do that is because we want to have some supplementary information per instances of our objects, like from where to get information, what's maybe the network address or hardware address or bus identifier to connect to obtain this information. Maybe you want to have some calibration information or the default settings for like sampling rate or whatever that might be. So this all the information we recommend to put in your as configuration entries or as cache variables, which are initialized with configuration, depending if you want to expose this into the address space or not. And pay attention that configuration is what your final user or what your end user, the user of your product or OPC-UA product, will see as one of the first things. So configuration should be tidy, should be clear, should be meaningful. The names of the config entries should be meaningful. Maybe they need some information like what's the unit. So refresh rate maybe should be called refresh rate hertz, or whatever unit you prefer here. We also covered how to access the information in the device logic, in the constructor, where you can naturally use this information to connect to your data source or data sink, and also how we can persistify this information for the whole lifetime of device logic object. Thank you for your attention, and see you in part 6.